Alright, we left off with our vertical angles theorem, and it told us that vertical angles are congruent. So what we know about these two angles, since they're vertical, we know that they're congruent. So that means that their measures equal each other. So, let me grab a pen. We'd have 2x plus 21 would equal 4x. So then now we'll just use our algebra to solve this. From here, we know we're going to subtract 2x from both sides to get our x's on one side. And that gives us 21 equals 2x. And then divide both sides by 2. And so these guys cancel. And that's going to leave me with x equals 21 over 2. Since 2 doesn't divide evenly, you can leave it as 21 halves. And I prefer that you leave things in fraction form over decimal form. So x is 21 halves. So same thing here. We have some vertical angles, which means that they're going to be congruent. So that means that 3x equals 2x plus 40. So to solve this, I'm going to subtract 2x from both sides. And that leaves us with x equals 40. So that's how you can solve problems using vertical angles. One thing that will be helpful is looking at pictures and making sure that you can process them. And here's some things that you need to be able to do by looking at a picture. You need to be able to figure out some relationships. There are some relationships you can assume to be true from a diagram that has no marks or measures. So otherwise you kind of have to be told. So we're looking for things with no marks and no measures. I was hoping to get my highlighter pen. There we go. No marks, no measures. So things we can figure out. We know that things are adjacent. We can find things that are adjacent and supplementary. That's going to be your linear pair. Or we could find things like vertical angles. Those don't have to be marked. You can just find them and know some things about them. From that, you should be able to know that they are congruent. Okay? Now, some things that you cannot just assume by looking at a picture. You cannot assume angles or segments are congruent unless it's marked. You have to be shown that in your picture. You cannot assume an angle is a right angle. So, say you had this drawn. This is not a right angle. But the minute I put that box in there, that is a right angle. So, this box right here, super, super important. Not a right angle unless you see it. And again, you don't know that angles are complementary unless you have it marked in your diagram that you have a right angle. So, let's look at this picture. What can you conclude from this picture? So, let's talk about some of these things. Do we have adjacent angles? Definitely. 1 and 2, 2 and 3, 3 and 4, 4 and 5, and 5 and 1. Those are all adjacent. Do we have any angles that are adjacent and supplementary? So I'm looking for a linear pair. Sure, right there. 3 and 4 are adjacent and supplementary. 4 and 5 are adjacent and supplementary. Do I have any vertical angles? Yes. I've got 3 is vertical to 5, so I know angle 3 is congruent to angle 5. And then I also have something else marked. If you see this line right here, those two little arcs let you know that those angles are also congruent. So I also know that angle 1 is congruent to angle 2. But I do not know if I have any right angles. I don't know if I know if there are any complementary angles. And I don't know if there are any other congruent angles besides 1 and 2 because they're marked, and 3 and 5 because they're vertical. What about this one? What can you make of the following conclusion in the information in this diagram? Segment TW is congruent to segment WV. So segment TW is here. So here's segment TW is congruent to segment WV. Well, here's segment WV. And yes, those are congruent because this little line right here, that is your congruent symbol. That is marked on your picture that those are congruent. So it's going to be important that you can look at pictures and figure out what can you tell from this picture. Another type of angle that we need to discuss is called an angle bisector. We did segment bisectors before, and that's where you had something that split a segment into two equal parts, whether it was a line, another segment, a ray, or a plane. So with an angle bisector, you have one option. Only a ray can be an angle bisector. And again, it's going to divide your ray into two congruent parts. So our multiple choice question here is ray AC bisects angle DAB. If the measure of angle DAC equals 58 degrees, what is the measure of angle DAB? So I need to be able to draw this to know which angle is which. Alright, so ray AC is my bisector, so that's the one going down the middle. And my big angle is angle DAB. And I know the measure of angle DAC here is 58 degrees. And my question is, what is the measure for angle DAB? Well, since this is a bisector, I also know that this angle is 58 degrees. And using your angle addition postulate, 58 plus 58 is D, 116. So what about this one? We've got ray KM bisects angle JKL. So let's go ahead and draw that out. So my ray is my angle bisector, which is KM. And it bisects angle JKL. So there's angle JKL. And I know that JKL is 72 degrees. So anytime you see this arc that goes all the way across the big one, that's letting you know the big angle measure is 72 degrees. And the question is, what is the measure of angle JKM? Well, since this is an angle bisector, I know that these are cut equally in half. So what is half of 72? It's 36 degrees. Good. So the measure of angle JKM is 36 degrees. And just one more or two more slides real quick. Some theorems that you need to at least know you've heard of them and make sure they make sense to you. If two angles are supplements to the same angle, then the two angles are congruent. So let's figure out what that means. 1 and 3 are supplementary, and it might help if you put numbers in there. So let's say that this is 50 degrees and this is 30 degrees. And we know that 2 and 3 are supplements. So if 3 is 150, that means that 2 also has to be 30. So we can figure out from there that 1 and 2 are congruent. It works the same way for congruent complements theorem. If 1 and 2 are complements, so let's go with 50 degrees and 40 degrees. Those are complementary because they added 90. And 3 and 2 are complements. Well, 2 is 50. That means that 3 has to be 40 to be its complements. Then 1 and 3 are congruent. They're both 40. So hopefully that makes sense to you. And last but not least, two more theorems. All right angles are congruent. Seems pretty simple, but we will need this one a lot this year. If you have one right angle, that makes it 90 degrees. You have another right angle, that makes it 90 degrees. Since they have the same measure, we know that they are congruent. And one more theorem. If two angles are congruent and supplementary, then each one is a right angle. So they have to be congruent and supplementary. Again, supplementary means they have to add to 180. If they're congruent, it means they have to be the exact same measure. So I've got two angles that are the same measure that add to equal 180 degrees. So they have to be 90 degrees and 90 degrees, which makes it a right angle. Alright, that's it for tonight. I will see you next time.